Hi, I'm Brother Guy Consolmagno, and I'm the director of the Vatican Observatory. Now, I'm not an expert in artificial intelligence, but I got friends who are. I was talking to an engineering friend of mine, Jerry, who's worked for many years in using computers to synthesize speech using what he calls neural networks. And so I asked him about artificial intelligence, and he came up with an interesting insight. He goes, "It's funny. Anytime something useful comes out of artificial intelligence, they stop calling it artificial intelligence. They'll call it machine learning. They'll call it, neural networks." I think what he's trying to say is there's a lot of good here, but there's also a lot of hype, and it's important to separate the one from the other. Language recognition is one of those things where artificial intelligence is used a lot, or neural networks, if you prefer. And anybody who's used Siri or Alexa or one of these voice recognition things with computers, you realize that it's not too bad compared to where it was even 5 years ago. But it's not perfect. It's not the same as talking to an actual human being. Back when I was a Jesuit novice, I worked for a couple of years in a sheltered workshop. This would be a workshop where men with mental handicaps, generally an IQ of 50 or below, were allowed to work together in a sheltered setting. And it was interesting because, as I say, they had an IQ of about 50, where normal is considered to be about 100. They couldn't count past 2, but they could all speak English with no problem. What I conclude from that is that what's going on in the human brain is different from what's going on inside a computer. And that's an important thing to keep in mind. Now, neural networks, as they say in this computer business, are based on the way we've seen how neurons in the human brain work. And that's a great model for putting together a kind of interesting computer system. But it's not the same thing as a human brain. My experience with neural networks, my experience with artificial intelligence is as a user of the data. I'm an astronomer. I deal now with the information that's coming from new telescopes, new sensors, where we have terabytes of data, more data than a human being can go through. And so we use these computer networks to sort out from all of these different data in an algorithm that's so automated we don't even understand what the computer's doing at any given moment, to sort out, all right, the data suggests this particular object might be an X-ray source. Let's go look at that with X-ray source tools. This other object might be where planets are formed. And that's all very useful. And it's, we couldn't do our work without it. But just because the computers are doing things we don't understand, it's not that they're doing things that human beings couldn't understand. We wanted to spend the time to work at it. It's still just data manipulation. It's still just clever programming. I had a friend in graduate school, a guy named Cliff Stoll. He was an astronomer who eventually became something of a computer maven. And when talking about computers, he has a phrase that I've never forgotten. He says, "Data is not the same thing as information. Information is not the same thing as knowledge. Knowledge is not the same thing as understanding. Understanding is not the same thing as wisdom." Computers are still basically dealing with data. I mean, the word intelligence itself is a pretty loaded term. We use these IQ tests, intelligent quota tests, which mostly test how well you can do on IQ tests. It assumes that intelligence comes in one single dimension. Now, I remember at the same time that I was working in that sheltered workshop, I also had a chance to go down to the Goddard Space Flight Center outside of Washington, D.C., a big NASA center. And I was there to keep up my astronomy as I was training to be a Jesuit. So I'm in the cafeteria, and I'm thinking, normally today I'd be having lunch with a bunch of men whose IQs are 50 points away from the norm, whose clothes don't fit right, who kind of stare off into space and you don't even know what they're thinking half the time. And then I'm looking around the cafeteria at Goddard going, yep, same thing. As somebody once said, going to Caltech, You look at the people there and you wonder, they all dress themselves in the dark? There's more than one kind of intelligence. And I've got to say, when I was at MIT, I was one of those guys that looked like he dressed in the dark. You know, if I didn't have a black shirt to wear, I'd probably still look like that. When I was at MIT, that's the other time I really ran into artificial intelligence. This was back in the early 70s. I was writing computer programs to try to model the moons of Jupiter. And my roommate that time was a fellow who worked at the artificial intelligence labs. He worked with Seymour Papert. He worked with Marvin Minsky. And so I'd hang out with him at midnight, you know, before going off to an all-night deli. I got to know these people. I got to see what they were doing. They were sharp people, but they were not godlike geniuses. They were just people who worked hard and had a clever idea of what they wanted to do. At the same time at MIT, there was a fellow teaching what they then called Introduction to Psychology, Hans Lucas Teuber. And what he was really teaching was not psychology like at any other university, but what eventually became known as brain and cognitive science. I would sit in on his lectures because they were so popular. I wasn't taking the class. Half the people in the lecture hall weren't taking the class. But he was just a fascinating storyteller. And it was from his work and the work at the Brain and Cognitive Science Department that we're able to map out all the different places of how the neurons connect. And we can attempt to imitate that in our computer designs. But that's the how of what the brain does. It's not the what of what the brain does. For that, you don't want a brain scientist. You want a philosopher. You want a theologian. I don't think you can come up with a better example than what St. Thomas Aquinas came up with when he described the soul as intellect and free will. The ability to recognize that I exist, to be aware of my existence, to be aware of the existence of others, and then to be able to be free to choose, what am I going to do about it? Am I going to try to cheat them, or am I going to love them? Now, that intelligence, that self-awareness, doesn't have a mass that you can weigh. It doesn't have a space that it takes up, but it's real. Consider the equivalent in a computer. Say you've got two laptops that are absolutely identical models running the same operating system. You can't tell the difference from one to the other except for maybe some scratches on the cover. One of them is going to have different files than the other. Now, the weight isn't going to be any different if the hard drive is full of data or not. And yet the computers are remarkably different. But what are those data? Physically, they're just, flips of magnetic core or little bits of however the data is stored. If you didn't have an operating system to display that on the screen, it would be just random gibberish. If you do have an operating system and it displays it on the screen, but in a language you don't know, maybe even in an alphabet you don't recognize, it's still random gibberish. It only has intelligence when there is a human being with intelligence looking at the screen. And so I come back to that insight of my friend Jerry. What we are calling artificial intelligence today is not intelligence. It's data. It's not knowledge. It's not wisdom. Will there ever come a time when human beings can manufacture things capable of having free will and intellect? Not only will it happens every day. There is no computer so powerful as the human baby. And human babies, unlike computers, can be manufactured by unskilled labor. What it does mean is if the day ever comes when we do have machines that have the ability to be self-aware, to have the ability to make free choices, we shouldn't expect marvelous things or have great fears. Because for all of our cleverness, the human race has never come up with new sins. The poor will always be with us because we will always be greedy. We will always be envious. We will always want to show the other guy up. But at the same time, we will also always have the virtues of faith, hope, and love. And a computer that's able to be self-aware is also a computer that will be able to love. Why should we ever be afraid of such a thing?